hope you've enjoyed building your Android apps as you work through this course. We've kind of reached the end of the practical part of the course, but there's still a couple more lessons where I want to talk with you about different things that will make your app better. And then in the last lesson, we're going to talk about how to publish to Google Play. So now what I'm going to talk about is permissions, performance, and security, and how to use them in your app to make your app more robust, make it faster, and make it a better experience for your users. So this is the contents. This is what we're going to cover. So permissions. So as you've worked through the course, there have been a couple of times when you've actually used permissions in your app. Your app needed permission to do something. So a specific example was in the practical where you connected to the internet to go search for books, right? You needed to add the permission to connect to the internet. And then in the lesson where you implemented a content provider and then you had a client app that wanted to use the data from a content provider, you needed to add permission. So you have already used permissions in your apps, we just haven't talked about it as a general topic. So when you create an Android application, when you create your project, the application has no permissions by default. It's created with no permissions at all. It can only use the things that it creates. And this is so that your app is not allowed to do anything that has a bad effect on the user's experience, on the user's data, on the device. Okay, it's to sort of control your app and constrain it. So when do you need to use permissions? When do you need to ask permission? An app must get permission to do anything that basically lies outside of the scope of the app itself. So if you want to use data or resources that the app didn't create, if you want to use the network, I mean, obviously the network doesn't belong to the app, right? It belongs to, I don't know, it's the network. Certainly not proprietary to the app, so the app needs permission to use it. The app needs permission to use hardware on the device, like the camera. The camera doesn't belong to the app, or any features that don't belong to the app. So the app needs to ask permission to do anything that affects the behavior of the device or affects the behavior of other apps. And all this is kind of common sense. It's just like hopefully your parents always told you, if it isn't yours, get permission. Don't just take and use something that isn't yours. And this applies to apps as well. So then the next question is, if your app needs to ask for permission, how does it do it? Just simply add the user's permission tag in your Android manifest. So here let's take a look what permission this app wants. Wants to read the contacts, wants to read the calendar, wants to use the phone to make a call. Wonder what this app wants to do. So here's some example permissions, right? Your app needs to ask permission if it wants to get the user's location. And obviously that would be the location of the device that the user's using. So whether you want the general location, which is known as the course location, like I'm in Delhi, or you want a specific fine location, the exact location, I'm on this street corner in Delhi, you have to ask permission to get the user's location. You have to get permission to use the network state or the Wi-Fi state. You have to ask permission to get the accounts on the device. That's obviously something that very much affects the user's private data. You have to get permission to receive SMS, to use hardware features like the camera. Have to get permission to record audio on the device because you'll be saving files outside of the scope of the app. If you want to modify the audio settings, make them louder or softer. If you want to add voicemail, there's actually a long list of permissions and they're all listed in the document linked here. So just a couple more examples, actually just 3 more examples. Have to get permission to use Bluetooth. You have to get permission to use the body sensors. So if your app's running on a watch that detects the user's heart rate or how fast they're running, that kind of thing, you have to get permission for that. If your app is running on a device that has fingerprint hardware, you have to get permission to use that. So this brings me to the subject of normal and dangerous permissions. So Android categorizes permissions in these very broad categories. And a normal permission is permission to do something that doesn't directly risk the user's privacy. So an example would be setting the time zone. The user's not going to be there the user's personal data is not going to be adversely affected if you set the time zone. Another example might be setting the volume louder or quieter. That's not going to infringe on the user's personal data. So for these kind of permissions, these normal permissions, Android automatically grants the permission. So Android doesn't bother to ask the user, do you grant permission for this? It just automatically grants those permissions. But even though Android grants the permissions automatically, your app still needs to request the permissions. Okay, so now dangerous permissions. These are permissions for operations that will give you access to the user's private data. For an example of this is reading the user's contacts. Okay, that's clearly something that's personal and private to the user. So for anything that's considered a dangerous permission, Android asks the user to explicitly grant that permission. And the user might say no. In fact, quite often I think the user does say no. So the next question is, how do users grant permission? Well, it depends on whether the app is targeted before or after the Marshmallow version of Android. So before Marshmallow, users needed to grant permission when they actually installed the app. So when you go to Google Play, you search for an app, then you want to download it and install it, Android will ask you, do you grant these permissions? So here the user wants to install the Blogger app, and Blogger's asking for these permissions. These are all kind of fairly reasonable things that you might expect a blogging app to need. So it's a reasonable thing, and very likely the user will grant the permission here. From Marshmallow onwards, when the user goes to install the app, Android doesn't ask them to give permission. It just lets them install the app. But then the app itself must get permission at runtime. So while the app is running, it must get permission. And Android will pop up a dialog box to the user asking the user to give the permission. So here, while the app's running, while Sneaky App is running, it wants to access contacts. So Android pops up this dialog box and asks the user, do you allow Sneaky App to access your contacts? So from Marshmallow onwards, when the user changes their mind about what permissions to grant, they just go into the settings, apps, they find the app they want to change the permission on, and they can revoke and set permissions, permission by permission. So in fact, every 5 minutes, if you wanted, the user could change their mind about which permissions they grant. So in this example, we see that the user has granted permission to Sneaky App to use its calendar, but Sneaky App's not allowed to use contacts, and it's not allowed to use the phone. So these differences in permission models are something that you, as a developer, need to bear in mind. Before Marshmallow, if the app was running, then the app can assume that the user gave all the permissions it needed, right? It's, when your app wants to do something that needs permission, it will just think, hey, I'm installed. The user gave me all the permissions I need, and it can go ahead and proceed. But after Marshmallow, your app cannot make that assumption because the user can change their mind whenever they want. So the app needs to get permission at runtime, and not only the first time, but every time you do something that needs a permission, you have to check, because those users, they can change their minds whenever they want and change permission however often they want. So starting with Marshmallow, which is Android 6, API level 23, the SDK includes methods for checking the permission. Do I have permission? Has the user granted permission? There are APIs for doing that. And you can actually just use the framework methods. But those methods have also been added to the support library, and it's much better to use the support library methods. And the reason it's better to use the support library methods is that they do the work for you of checking which version of Android is running on the device. Then Android knows to check whether the permission was granted at install time. So if you use the support library rather than the framework methods, you don't have to worry about writing conditional code, checking which version of Android you're running on. So just use the permission methods in the support library. So just a quick mention of best practices for permission. Some of this is pretty obvious. Your app really should only ask for permission for what it really, really needs to ask for, right? Don't ask for a ton of permissions that you don't need. One, it overwhelms the user, and two, it makes the user really, really suspicious. So just a quick example that came up for me the other day. One of my favorite apps is 2048. I like to play that quite a lot. It's just a little tile-based game. It's single user, doesn't interact with anybody or anything. It's just something I play when I have a few minutes. And generally speaking, 2048 doesn't need permission for anything. But I needed to change my phone, and I wanted to reinstall 2048 on my new phone. And I couldn't remember which 2048 I had downloaded, right? So I went to search on Google Play, and turns out there's a lot of different 2048 games. And I picked one kind of at random, and I went to install it, and it had clearly been created before Marshmallow, because it came up with a long list of permissions that it wanted, pretty much like this example here. It wanted my contacts, my calendar, the camera. I'm like, what? Why does it need these? So of course I didn't install it. And then I went off and I found a different 2048 that didn't need any permissions at all. And I'm happily playing my game again. So another thing to think about is when you need to use something like the camera or the fingerprint hardware, whatever, consider using an intent. In that case, you send an intent to for other apps to handle your request and send you back the data, and those apps need to take care of getting permission. So you don't even need to worry about asking for permission. So if you use an intent to use the camera, you don't even have to ask for permission for the camera. So that's really a much better model. And another benefit is that then you don't even have to write the code to interact with the camera hardware APIs, any of that. You just let the camera apps handle that for you. Okay, I'm not going to go through this. Lots of links about permissions. What I do want to talk about next is app performance. And what is app performance? It's basically, obviously, anything that affects the performance of your app, but it's things like the speed of your app, how responsive it is, how smooth it is, how consistent it is, and how much of your device's resources it consumes. Does it use a ton of the battery? Does it take up so much space that there's no space left for other apps? So you learned already about running tasks in the background. You use the async task and the async task loader to offload the work for connecting to the book search API. And one of the reasons that you have to do work in the background is that the UI thread updates every 16 milliseconds. So, the screen renders, displays to the screen every 16 milliseconds. So that basically means that the UI thread only has 16 milliseconds to do everything it needs to do between updates. So if the UI is waiting on a task that takes longer than 16 milliseconds, then the screen is not going to be responsive. It's going to stutter. It might drop frames. Worst case, your app might even hang. Everything you do on the main thread must be fast. And I think you already know at this point, how to offload work into the background and keep the main thread just for things that really relate to displaying things on the UI. So improving performance, it's something that you need to think about and be systematic about. While you're developing your app, everybody gets very excited. You build your app fast as you can. You may find you draw a bunch of views that overlap each other, or you may not get around to putting all your work in the background task. So, when you sort of slow down a bit, you've got over the excitement of the initial thrill of building your app, you need to go back and you need to examine your app and be systematic about how to improve performance. Gather information, gain insight. It's one thing to get the information about, this view took too long to display, but you need to figure out how and why, and you need to take action. And you need to keep doing that until your app is as smooth and as fast as it possibly can be. And actually, Android has a lot of tools to help you analyze performance. So I'm not going to go over all the tools for you, but I am going to talk about this one tool, the Profile GPU rendering tool. And what this one does is it lets you see graphically which of the screen displays is taking too long. So on your mobile device, you go to Settings, Developer Options, and then you need to kind of scroll down to the bottom to the monitoring section and select Profile GPU Rendering. And then you need to choose, there's a pop-up that comes up, and you need to choose on screen as bars so that you see it actually on the screen. You see the results of the tool on the screen. And then as soon as you do that, you'll still be in the settings app, and these bars, these little red, blue and green bars, then these bars, these little red and blue bars will actually start appearing on the bottom of your screen. Don't panic, your phone's fine. Just, this is the tool in action. And then what you do is you'd exit from settings and you'd open the app. Then what you do is you'd exit from settings and you'd open the app that you want to profile. And then you watch the bars go by at the bottom of the screen. So in the graph that shows up, one bar represents one screen rendered. And if a bar goes above the green line, that means that that screen took more than 16 milliseconds to render. That is, it took more than 16 milliseconds to display. So something was happening in your app that took longer than 16 milliseconds on the main thread. So if your graph has many bars above the line, or it has heavy spiking, lots of frames that take too long, maybe some that display in time, lots that take too long, like that, that indicates that there's a problem, a performance problem in your app. It's not that your app won't work or that it'll crash, anything like that, but it means that your app is not very performant. It's going to be slow and the user's going to see stuttering in the UI. So you can analyze the bars and fix the problems. So I'm not going to go into detail how to analyze the bars, but you can follow this link and learn more. I basically just want to raise awareness that there are tools. This is a really great tool. This is one that you can use very quickly, switch on very quickly and see it in action very quickly. But there's actually a lot more tools to help you analyze the performance of your app. So another thing to mention is Android Monitor actually has some nice tools for analyzing memory consumption, CPU, network. So the way you see these is just in Android Studio, you click on Android Monitor, and then you'll see these different tools come up. So the GPU one, for example, will look very similar to the GPU profile rendering tool that I just talked you through. If your app doesn't connect to the network, then obviously your network monitor shouldn't show any activity. If your app is a memory hog, you'll be able to see that in the memory monitor. Take some time to explore these monitors in Android Studio. So again, just sort of to wrap up on performance, don't make your users wait. If the user's trying to use an app and it takes too long, they're going to get bored, they're going to stop using it, maybe they just won't bother to use it anymore, maybe they'll uninstall it, maybe they'll tell their friends, hey, this 2048 is so slow, I'm never going to use it again. And then their friends will be like, oh, which version is that? We won't use it. Just in general, don't make your users wait, because it's going to have a really bad effect on how much they use their app. So some things to help keep the app flowing so the users don't wait. Your app can load data in the background whenever possible. It can pre-fetch data so it can anticipate when the user might need data and get that data in ahead of time. Move work off the UI thread, do things in the background, use async task loader, things like that. Optimize the UI. One thing you can do is actually draw less stuff. There's no need to draw more than you really need to. And another thing that you can do is, I'll talk about this in just a little bit, but eliminate overdraw and optimize the view hierarchy. I'll break that down for you. So eliminate overdraw. Overdraw is where you have a pixel, an area of the screen, and the app draws something, and then it draws something else, and then it draws something else, all over the same spot, right? So you're drawing 3 or 4 times over the same area of the screen, but only the very last thing that gets drawn actually appears on the screen. Everything else underneath, it was just wasted time drawing it. So sometimes it can be, it's fun to get carried away with, you draw a nice background and then you draw a view over it and then you draw a view over that, and just to really make things really pretty and stuff. But you want to be very careful about overdraw because it really affects the performance of your app. Again, it doesn't make your app throw an error, but it does slow it down. And then optimizing view hierarchy. What this means is that when Android is laying out your layouts, if you have a nested layout inside a nested layout inside a nested layout, that's going to be very much slower than if you have a layout with individual views inside it. So try and keep the hierarchy as flat as possible, as little nesting as possible. A little bit of nesting is fine, and Android can quite happily display however nested your hierarchies are. Android can display them. It's just your app's going to be a bit slower, and maybe you'll annoy your users a bit more if you have deeply nested view hierarchies. So other things related to performance are about using the battery. You need to be careful not to waste your users' battery, right? You don't want to use up all their battery so that their phone runs out of battery. So things that do use a lot of battery, for example, when your app does work over the Wi-Fi, or it uses the mobile radio, that actually uses a lot of battery. So your app should be considerate about these things. Batch the requests up together, and maybe use Job Scheduler to schedule those kinds of jobs so that they only run when the device is charged. So obviously if you want to use Wi-Fi, you have to be on the Wi-Fi, but it's also good to, as much as possible as makes sense within your app, to only do Wi-Fi operations while the phone's being charged. So images, I think we've talked about images a bit already in this course, but use the smallest images you can, because images take up space. A big image takes up more space than a small image. Use compressed image formats, and there's a new format called WebP, which is the best one to use when possible. And then another thing to consider is that when you get and put data on the internet, it uses up people's data plans, right? Most people have either a limited amount of data on their plan, or they have to pay by the byte. So either way that you do it, it's going to use up their data plan and cost them money. So if your app needs to get and put data over the internet, if you're using web services and you're transmitting a bunch of data, try and do that when the device is on the Wi-Fi so that you don't use up people's data plans. Here's some links to learn more about performance. So Android already has a lot of built-in security features, and it will do a lot of the security work for you. So at a very high level, you don't have to worry too much about the enabling security in your app. We already talked about the permissions model, where your app isn't allowed to do anything that it doesn't have permission to do. So that's one of the things that, that's one of the ways that Android keeps the app secure, protects them from each other. The built-in features take a lot of the work off you for making your app secure. So if you use the default system and the file permissions, and you're very good with your permissions, if you're very good with how your app asks for permissions, your app will, generally speaking, be fairly secure. But, of course, there's always a big but. Your app does have some responsibilities. Your app needs to keep the user's private data safe. We've talked about how your app can ask for permission to access a user's data. Hey user, can I have your email? Hey user, can I read your contacts? And the fact that the user says, yes, I give you my permission, doesn't mean you can do what you want with their data. Doesn't mean your app can do what it wants with their data. You have to use users' data with integrity and honesty. Your app has to do absolutely everything it can to keep the user's private data safe, right? Just because you're allowed to just because your app's allowed to read the user's contact list, doesn't mean your app has to, should, or that it can share it in any way, right? Your app has to keep the user's data safe. Don't leak secret things. Treat the data with integrity. That's the same, basically what we just talked about. But then the other responsibility you have, or that your app has, is that your app has to keep its own data safe, right? So if the app generates data, don't just make that data accessible through a content provider, writable and readable by the world. Be careful about what permissions you grant to your own data. Only get the data if you really absolutely have to. And as far as possible, do not store or transmit it, because the act of storing it or transmitting it, for example, sending it over the internet, is opening it up to security vulnerabilities. So if you absolutely must store the user's data, or you must transmit it, you must send it, consider using a hash or a non-reversible form of the data, so that, if anybody's snooping, they don't get the plain text version of the user's data. So for example, use a hash of an email address as a primary key, so that you don't store or transmit the email address. I'm not going to go into primary keys too much, but I just really need to raise awareness with you that your app really needs to be very, very aware of being careful with users' private data. Now, depending on what private data your app uses, if it does use it, might not, but if it does, there will be times when your app actually has to have a written statement about how it uses the personal data. So you may actually need to attach a privacy policy to your app. Logging. Yes, this is something you might not think of, but logs are a shared resource. So you don't want your app to write to the logs, the user's email in plain text, because other apps can read the logs. Any app can read the logs if it has the read logs permission. So be very careful about what you log regarding private user information. So if your app does use sensitive data, like the user's email, so if your app does use private data like the user's email, you need to encrypt it. And you encrypt it generally using a public-private key. You need to store the keys safely. You need to remember where you stored it. I'm not going to go into details of how to use keys and key stores. You can follow this link if you need to. But if your app does use sensitive data, it must encrypt it. Another thing to think about is external storage. Not that many devices now actually have the little SD cards that you can take in and out, but some still do. And you have to be careful about storing information on external storage. First of all, the external storage is available to any app that requests permission to it. So you definitely don't want to store private, secret data on external storage. The other thing, and this isn't so much a security issue, but sort of an app usability issue, is if you store your app's data on external storage and the user removes the storage, like they take the SD card out, then that data is no longer available to your app. So just generally speaking, don't store data on removable external storage. And again, the external storage is accessible to any app that requests permission for it. Another thing to be aware of is that when you get data from outside of the app, like from external storage or even from down over the internet, you need to validate the input. You need to make sure that the data that you're bringing in from the other place doesn't have security vulnerabilities in it. And then again, just a word about networking. Android is basically a Linux environment, and the networking on Android is similar to other Linux environments. So, generally speaking, transmitting data over the network is not the most secure thing that you can do or that an app can do. So minimize network transactions that transmit private data. Use HTTPS instead of HTTP if you can, because that helps protect the user. And always remember that a lot of users, I'm sure you're the same, I know I definitely am, we use our mobile devices in places that have public Wi-Fi, because then we don't have to use our data bandwidth. And usually this public Wi-Fi is not password protected. It's very often not password protected. So be very aware that your users are using your app on a device on an unprotected network. So just bear that in mind as you're developing your app. And then if you want to implement authenticated, encrypted, socket-level communication, you can use the SSL socket class, and I leave that to you to investigate. I just want you to know it is an option, but a better approach is to just minimize the use of private data. So there's lots of links here for learning more about security in Android. That's the end of this lesson. As I said, this lesson has no practical, so you may still be working through your practical books. By all means, go ahead and finish that up. The next couple of lessons will cover a couple more topics, introduce you to a couple more topics, and then we'll talk about how to prepare your app and publish it on Google Play. Thank you.